1.1 Part 2 Linear Word Problems. I would take a minute and pause the video to give you some time to write down example 1 because I'm going to dive right into the solution. So it says, a car leaves Austin traveling 40 kilometers per hour. 4 hours later, a truck leaves Austin following the car and traveling 65 kilometers per hour. How long will it take for the truck to overtake or pass the car? So let's think about what this is really asking. So let's kind of draw a picture. So here's Austin, okay? So it says that a car is leaving Austin at 40 kilometers per hour. All right? A truck leaves 4 hours later and is traveling at 65 kilometers per hour. So here's our truck behind at 60 kilometers per hour. Okay, how long will it take for the truck to overtake or pass the car? What we're looking for is when are they going to be at the same point? Okay, the truck started 4 hours later, so it has some catching up to do. So we're trying to figure out when are they going to be at the same spot. So first thing you want to do is you want to set up a variable. Okay, the question asks how long will it take for the truck to overtake or pass the car. So what I'm going to do is I'm going to say that my variable I'm going to use is t, and t is going to represent the time for the truck. Okay? Then I need to figure out how I'm going to set this all up. So we're going to use a chart for these problems, hopefully to keep you organized, and then you can see kind of a pattern and how to set up these distance problems each time. So if you recall, I'm sure you learned sometimes that distance is equal to rate times time. Distance is equal to rate times time. So we're going to use that to help us solve this problem. So I'm going to scroll up a little. All right, what we're going to do is we're going to set up a chart. So we have two vehicles going on here. We have the car and we have the truck. All right, the car and the truck have some distance that they're going. They are traveling at some rate and they are traveling for some amount of time. So distance equals rate times time. You can think about it that way. So distance equals rate times time. All right, so let's fill in the easy ones. What you're going to do each time when you set up this chart is you're filling in the rates and the times. Okay, the rates and the times. So the rates are easy in this problem. We have the cars traveling at 40 kilometers per hour. The truck is traveling at 65 kilometers per hour. Now, we said that T represents the time for the truck. Okay, so we're going to say T. The truck is on the road for T amount of time. I don't know how long that is. Okay? Now we have to come up with how long is the car on the road? Well, the car left 4 hours earlier. So it's on the road for the same amount of time as the truck, but that extra 4 hours. So we're going to write that as T plus 4. Okay, so the amount of time the truck was on the road plus the 4 hours, it was 4-hour advantage it had. Okay, so you're always going to be able to fill in these rate boxes and time boxes. All right, now we know mathematically that distance is equal to rate times time. Now that you have your rate and your time in these boxes, we can find the distance of the car and the distance of the truck by multiplying rate times time. So let's look right here. Distance is going to be rate, which is 40, times the time, which is t plus 4. So the distance for the truck, again, we're going to multiply rate times time, is going to give me 65t. Okay, so again, you're going to always fill in the rate boxes, fill in the time boxes, and then you're going to multiply them to get your distance boxes. Okay, we're going to use that information to set up our equation. So again, going back to my picture, I have the car traveling, I have the truck traveling. I want to know when they are at the same spot. Well, they're going to be at the same spot when they are at the exact same distance. So we really want to know when are those two distances equal? When is the car's distance equal to the truck's distance? So in order to set that up, I'm going to take the car's distance, which was 40 times t plus 4, and I'm going to set that equal to the truck's distance of 65t. Okay, again, I want to see when they're at the same spot or at the same distance. Now that I have it set up, I'm going to go ahead and solve. So on the left-hand side, I'm going to distribute 40 times the t and 40 times the 4. 40 times t gives me 40t. 40 times 4 gives me 160, is equal to 65t. All right, I'm trying to solve for t, so what I'm going to do is I'm going to subtract 40t from both sides. That leaves me with 160 on the left-hand side is equal to 25t on the right-hand side. Trying to solve for t, so I'm going to divide both sides by 25. Okay, and the directions tell us, if I go back up here, round to the nearest tenth. So when you do 160 divided by 25 in your calculator, you're going to get t is approximately 6.4, and the time, the units, is hours. Okay, so let's go back up, read the question, make sure we've actually answered it. The question is, how long will it take for the truck to overtake or pass the car? We came up with that t is equal to 6.4 hours. Well, what did t represent? So if I go back up here, t was the time for the truck. That's what they're asking about. So this problem, t is equal to 6.4 hours, is our answer. Example 2. Again, please pause and make sure you have this written down in your notebook before we start. 2 boats leave at the same time from a city to go to the same island. The first boat travels at 28 miles per hour. The second boat travels at 42 miles per hour. And how many hours will the 2 boats be 60 miles apart? Round to the nearest tenth. All right, so again, let's try to draw this out, see what's going on. So let's say here's where they're leaving from, okay? We have one boat going 28 miles per hour. We have another one going 42 miles per hour. And they're going to the same island. Here's my island. Well, if they're going at different speeds, do you guys agree, hopefully, that this boat is eventually going to get ahead? Okay? Well, we know that this one's going to be ahead because it's going faster. So they want to know, hey, when are we going to be 60 miles apart? When are we going to be far enough ahead that we are actually 60 miles in front of the other boat? Okay, so let's figure out how we're going to set this up. Remember, in the last problem, the first thing you always want to do is decide what your variable is going to be. Okay, it says in how many hours? How many hours? So they're asking us for time. So I'm going to use my variable as t again. I'm looking for a time. Okay, well, do you agree that if they leave at the same time, they're traveling for the same amount of time? Okay, if they both leave this place at the same time, they're all out in the water for the same amount of time. So this t is actually going to represent the time for either, or actually the time for both. Okay, both of the boats are out in the water for the same amount of time. Okay, so they're traveling in the same direction. Once I have my variable set up, remember, I'm going to do my chart. So I'm going to say I have boat 1 and I have boat 2. All right, let's set up our chart. Remember, we know in our chart, I know this is not the best, that distance is equal to rate times time. Okay? How fast are the boats traveling? That's the easy part again. We have boat 1, we'll say, is the boat that's traveling 28 miles per hour. And then we have boat 2 traveling 42 miles per hour. Okay? Then remember, we're going to be able to fill in these time slots as well. Well, we just talked about it, that the boats are leaving at the same time. So they're going to be on the water for the same amount of time. So we, in this case, can call both of them T. Okay? Remember that this distance column right here is always filled in by multiplying the rate and time that we have over here. So this distance of boat 1 is going to be 28t. distance of boat 2 is going to be 42t. Okay, now I have the distances. Remember, the question is asking us, and how many hours will the two boats be 60 miles apart? 60 miles apart. So what we want to know is, when is the difference between these two different distances going to equal 60? So like I said, when is the difference between these two distances? So we're going to take the biggest distance first, the boat that's furthest. The difference means minus in math. So 42t minus 28t. When is the difference between those two distances equal to 60 miles? Okay, now I have my linear equation set up. So I'm going to go ahead and solve. 42t minus 28t is giving me 14t equals 60. Divide both sides by 14, and I get t is equal to approximately 4.3, and then we're talking about time. The units are hours. So it'll be about 4.3 hours. Whoop, sorry about that. Let's undo that. There we go. 4.3 hours for these two boats to travel and become 60 miles apart from each other. All right, please pause and make sure you have this written in your notebook before we begin. Example 3. Anna drove for 5 hours on secondary roads at a steady speed. She completed her trip by driving 4 hours on an interstate highway. Her total trip was 450 miles. Her speed on the interstate highway was 18 miles per hour faster than her speed on the secondary roads. How fast did she travel on the secondary roads? Okay, so again, let's kind of see what's going on here. So we have Anna driving. She's on a secondary road, so we'll say this is like a crazy squiggly road. All right, that's her secondary. She's on the secondary road, and she completes her trip by going on the interstate. So we'll say the interstate is more of a straight road. Okay, so she's on the secondary road for 5 hours. She's on the interstate for 4 hours. Okay, her total trip, so from beginning to end, was 450 miles. She traveled 450 miles. Okay. The other thing we know is that her speed on the interstate highway was faster. She was able to go 18 miles per hour faster on the interstate. Okay? So, as usual, we first want to set up a variable, figure out what our variable is going to be in this problem. Well, the question asks, how fast did she travel on the secondary roads? How fast did she travel on the secondary roads? So I'm going to say x. I'm just using x this time because x is a common variable. X is going to be equal to her speed on the secondary road. Okay, it's the speed on the secondary road. And I need to specify which road I'm talking about because she has different speed on the secondary road than she has on the highway. So I'm specifying that x is going to represent how fast she's going on the secondary road. All right, so then we need to go ahead and set up our chart. We know, same chart we've been using. This time, we have the secondary road and the highway. Okay, those are our two pieces of information, secondary road and highway. So again, then we have distance, rate, and time. Okay, we know distance is equal to rate times time. Just like before, we can fill in the rate column and the time column. Okay, so the time one is what's easy in this problem. I know that she was on the secondary road for 5 hours. She was on the highway for 4 hours. All right, the question is, how fast did she travel on these roads? So this is where my variable is going to be this time. We already decided that x is going to be the rate on the secondary road. Okay, if you wanted to use r, you could. Okay, so we don't know how fast she's going on the secondary road, so we're going to call that X. We do know that on the highway, she was driving 18 miles per hour faster. So we're going to represent that by X plus 18. Okay, 18 miles per hour faster than she was on the secondary road. All right, and you guys remember, to get the distance, we're going to multiply the rate and the time. Okay, so rate times time for the secondary roads is going to give us 5x. All right, rate times time for the highway, I'm going to write it out, 4 times x plus 18. Okay, so now we have to figure out how we're going to set up our equation. Okay, I know it's going to have something to do with these two distances. Well, we have to look at what's happening in this problem. What other piece of information do I have? Well, if I go back and look, it tells us that she drove a total of 450 miles. Total in math, we can think of addition. So we're going to take the distance on the secondary road and her distance on the highway, add those together, and that should give us the total distance. So I'm going to take the distance on the secondary road, which is 5x. I'm going to add it to the distance on the highway, which is 4 times x plus 18. Those two distances added together should give me the 450 miles that she's traveling. Okay, then I'm going to go ahead and solve that. I'm going to distribute, so 5x plus 4 times x gives me 4x. The 4 times 18 gives me 72 is equal to 450. Combine like terms, 5x and 4x gives me 9x. So 9x plus 72 equals 450. All right, solving for x, so we're going to subtract 72 from both sides. 9x is equal to 450 minus 72 is 378. Divide both sides by 9, and I get x is equal to 42. Okay, well, what did that x represent? X represented the speed on the secondary road. Okay, so on the secondary road, she traveled 42 miles per hour. The question asks, how fast did she travel on the secondary road? So we are done with this problem. We figured out that she traveled 42 miles per hour on the secondary road. Now, just for your information, if the problem had said, how fast did she travel on the highway, we would just take that 42 and add 18 to it to see how fast she would be traveling on the highway. So she traveled 60 miles per hour on the highway. Okay, this question just asks the secondary road, but be aware that it could ask for the speed on both, or it could have asked for just the speed on the highway. Example 4. Take a minute and write this in your notebook. Please pause the video and start when you're done. Two cars start out together from the same place. They travel in opposite directions, with one of them traveling 5 miles per hour faster than the other. After 3 hours, they are 405 miles apart. How fast is each car traveling? Okay, so again, let's kind of get an idea of what this looking like. It says they start out at the same place. Here's where they're starting. All right, they travel in opposite directions. All right, one of them is traveling 5 miles per hour faster than the other. After 3 hours, they are 405 miles apart. So here they're traveling away from each other, and then eventually they are 405 miles apart. And that took a total of 3 hours. Okay, so first thing you want to do is figure out what you're going to call your variable. Okay, in the last problem I used x. This time it says how fast is each car traveling. I could use x again, but this time I'm going to use r for rate. Okay, so what does r stand for? R is the rate in miles per hour of one of the cars. Okay, I need to pick which one. I'm always going to use the slower car. Okay, so my R is going to stand for the rate of the slower car. okay, because they're traveling at different rates. Now, once I have that established, I'm going to go head down and set up my chart. All right, so I have, whoop, not so great. I have my slow car, and my other one I'll label as my fast car. Make sure you distinguish between the two, okay, or it's going to get confusing. We know we're going to have distance, rate, and time. Okay, so let's fill in exactly what we know. Okay, let's fill in exactly what we know. Do I know the rates of either car? No, I see that that's my variable. I don't know how fast either car is going. So for now, let's leave that blank. Time. Do I know how long each of these cars were on the road? Well, this one I do. I know that they left at the same time, and we're talking about 3 hours going by. Okay, so they're both traveling for 3 hours. So since I have my T column filled in nicely, I know that my rate is going to use that variable. Okay, I know that the slow car is traveling at R miles per hour. We know from the problem that it says one of the cars is traveling 5 miles per hour faster. So I'm going to represent that by R plus 5 miles per hour faster than the slower car. Okay, now I know that I'm always going to fill in my distance column by multiplying the rate and the time. So the slow car's distance is going to be represented by 3R. The fast car is 3 times R plus 5. Okay, so now once I have everything filled into the chart, I have to figure out how I'm going to set up this equation. What makes sense? Okay, so going back, the last piece of information that I haven't really used yet that I'm going to use to create my equation is that they are 405 miles apart. Okay, where does that 405 miles come from? Well, it comes from the distance the one car is traveling plus the distance the other car is traveling. Those two distances together is going to give us the 405. So I'm going to take and I'm going to add those two together. So the distance of the slow car, 3R, plus the distance of the fast car, 3 times R plus 5, should equal a total of 405 miles. Okay? And then I go ahead and simply solve this. 3R plus, I'm going to distribute. 3R plus 15 is equal to 405. All right, 3R plus 3R is 6R. So 6R plus 15 equals 405. Subtract 15 from both sides, I get 6R equals 390. Divide both sides by 6, and that's going to give me R equals 65. Okay? So again, always go back and read, see what the question's asking for, and let's make sure we answer it. How fast is each car traveling? Well, we got down here, we got R equals 65. R represented the rate of the slower car. So the slow car is traveling at 65 miles per hour. Then we have to make sure and tell how fast the fast car is traveling. The fast car is traveling 5 miles per hour faster, so the fast car is traveling 70 miles per hour. So this problem asks for 2 pieces of information, so always go back, make sure you've actually answered the question.